So, the normal way to actually encrypt the hard drive is already standard, and you use it by using looks. It's called looks for some reason. It's not really a problem, and when you boot it looks like this. And actually in text mode, nowadays it's all graphical and stuff, but in text mode it looks like this. And let's see now, okay. Fine. Okay. Now, normally on the computer's hard drive it looks like this. You have a boot partition which is unencrypted, and the rest of the disk is encrypted. That is, if you install with encryption, as I showed you before. You can do it in one step, in Debian and Ubuntu actually. In Ubuntu you have to pick either the alternate install CD or the text mode install, but not the graphical install, but then you can choose it in one step. Anyway, now you get, in that case you get this type of thing. In the Mandos system, we add a small OpenPGP key in the unencrypted partition. Then we have a Mandos server on the same local network, and at boot, it sends it, it connects from a small client program and connects via TLS encrypted using the OpenPGP key to the Mandos server over the local network. The server looks up the fingerprint of the PGP key in the list it has. Okay, it says, oh, it's this fingerprint. I should send this binary mysterious blob to the client, and it does so. So, the OpenPGP key then is used to decrypt this blob into a password, and the password is then used to decrypt the encrypted hard drive, which is the real hard drive, which is used for the rest of the system. So yeah, that's the basic design. More clicks on this. Oh, yeah, we use zeroconf, and Apple users may know this as bonjour to actually find the servers on the local network automatically, because when you're booting, this is like before we have an IP address configured on the local client computer, so we can't use normal IP communications there. So, and we also use, as I said, we don't have IP addresses even, so we have to use IPv6 because they always have something like called link local addresses, and they're always there and always useful, even though nothing is configured. So yeah, this is a more technical overview. Let's see if there's anything useful here, only to confuse people. Okay, fine, skip this slide, just confusing. Ah, yeah, this is a more technical description of how the client side of it works, and the server, apparently. Maybe I can point at this thing. This is the Mandos client computer, which is connected to a local network server here. This is the Mandos server process. We'll talk about that later, I think. And the client program runs a plugin runner, which starts a number of plugins. This plugin asks for the passwords at the text prompt, as usual, as you saw before. So you can still type in your password, that's not a problem. And then if you have a graphical password prompt, you have a plugin for this, and there are many graphical plugin prompts, we have many, just like this. There's a backward compatibility thing, and you can also write your own plugins really easy. And then you have our main magic plugin here, which is actually the Mandos client thing, which actually communicates over the network with the server. But since you have all these plugin things, you can easily customize this to your Arch content. And this is basically it. This is the address for the homepage of the project. It's available now in Debian Unstable and Ubuntu. There's a small bug, but we hope that they'll fix it because it's not our bug. It's a library we use, but they changed it and now it doesn't work anymore. But it still works if you compile it and install it from our repository into Debian Unstable. It works perfectly. Anyway, this is the graphical password prompt that you normally get. Plug in the network connection. You could type in the password now, if you wanted to. But then, since we have a network now, it suddenly detects it and has already transferred the password from the computer over there. And now it's continuing to booting up. You can use this on servers, and as long as one other computer is on the local network, you can reboot the server remotely without any problems and still have encrypted disks. Question?
Yeah, I was thinking about the architecture. Is it possible to have like a Mandos server on multiple machines?
Yeah, sure. Yeah, we thought of that.
Actually, one of the principles behind the idea that as long as one machine up, it will boot up the other one machines. Now you don't need to actually have one Mandos server on every machine, but it could have. And something is going like say you had a mobile phone, but you don't have it nowadays, but you could have. So it could actually authenticate your computer when you have it in pocket, but as long as you're not near it, it won't work. So basically, and if someone went in and actually, common ideas, when someone steals your stuff at home, it doesn't go slowly, try to mess around with one computer. They're going to take everything and can away. Or if someone walks into a nice data center and looks very kind of like one of your computers, again, it's going to take everything away and sort out the rest later. And if that happens, everything will just shut down. That's the whole idea. If everything's dead, it stays dead. But as long as everything looks normal, then everything is probably normal, and your computer will boot up normally.
More details. Multiple Mandos servers on the same local network will not conflict. Mandos client will try all of them in turn and try automatically new ones as they appear until it gets a password it can pass on. So it works perfectly with multiple Mandos servers to boot up each other, and we thought of that. That's how we use it ourselves. Anything else? Sorry? Oh yeah, the server actually checks that the clients are still alive using some method, because if the client, you can bypass this pretty easily if you know what you were doing, but it's not really that big a danger because people are still going to turn everything off and carry it away. Question?
Quite common, I don't know how commonly, but if I were to steal 5 of your computers and keep one on in my car with a battery, would I still be able to boot the 4 other computers then?
The question is, if you stole all of them and you kept one on the battery, will you still be able to boot up the rest of them? The answer is no, because the other machine has been down too long. Because that's the thing what I was going to tell you about. No, it's my mic. The server, by default, the server pings all the other machines, and if they have been down too long, you can configure that. The server stops sending out the key for those machines.
It's actually called heartbeat system.
Yes, and it's actually configurable, so you can actually make how complicated system you want. Yes. So you can actually make it so advanced that they actually check, authenticate that it's really a computer. You can have some really advanced hardware to check they are connected to, something especially. You can make this how much you want. It's all configurable. By default, we do fping, simple ping, just to But there's a very simple to implement.
And you have a table with time, which is supposed to respond with it.
Yes, it's a timeout.
It doesn't, it disconnects the connection.
Yes, there's a timeout for each client. So yeah, that's basically it. That's the Mandos system. That's why you can now, using this system, use encryption on your service, and you should use encryptions on all the machines you could use encryption.
Encryption is not only for hiding something, it's for keeping control of what you have. That's all I want to say.
I think we're done.